Good afternoon. My name is Farah Guerrero, and you are listening to the Blue Hour here on CITR 101.9 FM in Vancouver on the beautiful UBC campus. My guest today is Dr. Paul Bartha, professor of philosophy and acting department head at the University of British Columbia. And before we begin our conversation, I'd like to make a land acknowledgement to acknowledge the unceded and traditional ancestral territories of the Musqueam people. Now, Professor Bartha is one of the leading philosophers working on analogical reasoning. He is the author of the Stanford Encyclopedia of Philosophy entry on the subject, and the book By Parallel Reasoning, the construction and evaluation of analogical arguments. He researches logic, decision theory, and philosophy of science, and he explores how analogies, even the everyday ones, help us understand science, philosophy, and life. And more recently, his work has focused on another question. It's about how we can make decisions when there is a possibility of something going wrong. So whether we're talking about pandemics, climate change, or energy policy, when the probabilities are uncertain and the usual tools of decision making may be inadequate. So today we're going to explore some of these themes. We're going to begin with something called precautionary reasoning, and then hopefully move into analogical reasoning, because I am sitting here with an expert. And we may get on an exciting topic about this beginning of understanding analogical reasoning in this new world of artificial intelligence. So how do we grapple with that in this, and what it means to reason in an age of uncertainty? So Paul Bartha, thank you for coming to the Blue Hour.
And thank you very much, Farha. I've got a big smile on my face because it's always fun to talk about these esoteric ideas. I appreciate your patience, and I hope I can explain things to you and maybe to some of the listeners.
Absolutely. I have no doubt you will.
So, yeah, I mean, I guess anybody who likes philosophy is drawn to questions, right? Because philosophy is better at giving questions than giving answers sometimes, although I'm interested in answers. And I'm especially drawn. I thought you might ask me what's the common idea behind these topics, right? And I think it's the fact that we've got pretty well developed models of what's called rational choice or modeling belief change, but there are these topics that kind of live in the dark shadows that modes of reasoning people use a lot, and it's much harder to capture them. And analogical reasoning is one of them.
Yes.
It doesn't fit very nicely in the standard kind of models of reasoning.
Yeah. And
precautionary reasoning is another one. Like there's lots of missing pieces in your knowledge, and it's much harder to fit it into the paradigm of good decision making, these models we have. So anyway, I'll stop talking. But these are
what strikes me is what you said. So analogical reasoning and precautionary reasoning seem to emerge maybe from the same human predicament, that we rarely have complete information. And so that's what you're after, right?
That's kind of that's part of it. Like I actually, when people talk about the precautionary principle and precautionary reasoning, part of the motivation for this principle is sometimes we need to make decisions quickly, which have huge consequences. There are huge things at stake. And the standard cost-benefit model, sometimes it's called, or standard decision theory, or there's lots of names for this mode of reasoning. The basic idea is you carefully enumerate all the options. Then you also identify what possible states the world could be in. You assign various values to the different outcomes. You think of it almost like a table. Yeah. The states are the columns, the decisions, possible acts are the rows, and at each intersection there's an outcome. And you say, okay, this is the value I would assign. Yeah. You use an abstract number called a utility, or a monetary value for economists, And then you assign probabilities. What's the chance of this outcome arising if I take this act and it's this state? If you're thinking of something like, should I bring an umbrella? It works very well. It's either going to rain or it isn't. I would assign this a very low value. If it rains and I forget my umbrella. So anyway, and you figure out probabilities, and then you calculate what's called expected values for each act. It's a kind of a statistical average where you weight the utilities by the probabilities. And it's kind of like gambling, right? Like, is it worth doing this act? Is it worth doing that act? Which one has the highest expected value, right? And that is a really good model for most decisions, but you kind of need to know a lot. You need to be able to estimate these probabilities and the values, and then you can do this. But often in life, we're faced with huge uncertainty, and we don't even know our values. So one motivation for precautionary reasoning is, there are cases where we're faced with enormous looming catastrophe, climate temperature rise. We don't know exactly what the probabilities are. We actually are starting to get pretty decent estimates of higher probabilities than people might have thought in the past. But in these cases, we don't want to wait until we have all this information. So we need tools for reasoning. There actually are tools in decision theory for reasoning under uncertainty, but the precautionary reasoning case is sort of in the middle. You know something about the probabilities and something about the values, but you need a way to make a decision.
Now, you recently gave a lecture about precautionary reasoning. So why don't you take us through that a little bit? And you shared a wonderful slide show with me. Let's talk about it. Let's break it down and how. And even before we begin, what first drew you to this
topic?
Of research? Yeah.
Yeah. So not what drew me to philosophy, but what drew me to this topic. Well, actually, I kind of got into this through a back entrance, I guess, because, and this could come up, but I was interested in Pascal's wager, which is a classic argument in philosophy. It's one of the most famous arguments in philosophy, and I don't think the argument succeeds, but it's an argument that you ought to wager, as it were, for God. If you have a choice between trying to adopt a religious point of view or not, and either God exists or doesn't. It's the same kind of table I was talking about a minute ago. Pascal famously said, well, look, there's a possibility of an infinite reward if you believe and God exists. If you wager and God exists, there's an infinite reward. All the other outcomes in the table are at most finite. Like maybe there's a small gain. You're certainly better off not believing if God doesn't exist, but it's a finite gain. So as long as there's some probability that God exists, the expected value of wagering is going to be infinite.
Yeah.
So I was fascinated by this argument, but most people aren't that excited about that argument, but they're much more interested in infinitely bad things. So
I like that.
And that's kind of where this stuff came. I realized exactly the same kind of structure comes in with these precautionary arguments, because there's a chance of some terribly bad thing happening.
Yeah.
And that seems to outweigh the goods. And, is that wise to reason in that way? And all the same objections that have been raised against Pascal's wager, the same objections apply to this precautionary reasoning about the environment.
Yeah.
So I didn't get into this through environmental ethics, but now I'm interested in environmental ethics.
You absolutely are.
Yeah.
And so in your slideshow, you bring up things that are very familiar to us. So the pandemic, right? And some of these debates that are ongoing about pipelines, and certainly climate change. And so your new research is really pulling, I think, a lot of in some interesting directions that are really pertinent to today's world.
So actually, I years ago, I was a fan of Buffy the Vampire Slayer, and there's some line about what's the plural of apocalypse or something, like apocalypses. And we're faced with a whole bunch of apocalypses now, right?
Yeah,
There's
apparently.
There's the pandemic, of course. There's the AI extinction.
Yeah.
There's all
just
this
a few
weird
wars going on, and there's nuclear possibilities.
There's genetic tinkering with designer babies and all this weird stuff. So it's true, we're in a golden age for disaster and apocalypse.
Yeah.
So this, I will admit right off the bat that this this stuff is at the I don't know what you would call it, alpha stage or something. It's not something I would dare to apply to. Like I do actually. There are some examples where I've tried to apply it to decisions. But actually, one of the things I argued in this paper. So the first thing I tried to do was to explain that there might be cases where we want to use this normal reasoning. Most of the time, just normal cost-benefit reasoning is perfectly appropriate. Yes. But when there's uncertainty about probability and when there's something catastrophic, and actually, I think this is true, even if you do have a pretty good grasp of probabilities, you might still want to use some kind of precautionary reasoning because there's this sense that standard cost-benefit reasoning doesn't help protect the things we care about the most. And the thing that I thought comes out in the beginning of my talk, and by the way, that talk, it was my presidential address. I was the president of the Canadian Philosophical Association until about a week ago. So that is over now.
So now did you retire?
It's a 1 year. It's only 1 year. I'm now past president. So
but was this the conference?
That was the conference. Yeah, the Canadian. It was in Halifax.
Oh, it was in Halifax. Yeah. Okay.
So that my year of living administratively is coming to a close. I won't be department head. I won't be president of the CPA anymore. So, but anyway, the idea that I tried to get across was that this notion of catastrophe is kind of a relative one. It's more, it can be applied to existential threats, but it also applies to kind of local perceptions of something being catastrophic. Locally, there was something like a local catastrophe. So I had the example of Northern Gateway,
which is really a good one. Yes.
And that was, it's come back now. So when I first started thinking about this about 10 years ago, it was just before the Liberal government killed this Northern Gateway idea, which was building a pipeline from Alberta to, I think it was the Douglas Strait, and there was going to be a pipeline that would carry the bitumen, and then it would be loaded on tankers, and the tankers would steer around this treacherous channel. Yeah. And I think I had a quotation in the paper I sent you from an Indigenous, Larry Newski. I think he's a local Indigenous leader, and he said, like, nothing would ever persuade us to take this chance. Yeah. We don't care. This is valueless for us, this whole thing. And I thought, that kind of the thinking I'm interested in is people who won't make trade-offs, who won't compromise. Yeah. And that, to me, is characteristic of precautionary reasoning. So even more than ignorance of probabilities, I think the hallmark of precautionary reasoning is when there's some discontinuity in value. Yeah. Some outcome is so bad that you're not prepared to take any gamble. Absolutely. And many people would say that's irrational. Like, everybody, we make these gambles every day. When we get in the car, we take risks of a car accident. You'd be paralyzed. And I understand that objection. And it's something, I think I have a way to answer it. But I think there are certain, like, big one-off decisions where you're doing a much better job of capturing the reasoning by modeling it in this kind of no trade-offs, no compromise way. And I think it would be wrong to adopt a formal decision theory framework that makes that irrational right from the get-go. That's so I'm trying to develop a formalism that allows that kind of reasoning to be potentially rational, right? So that's sort of the idea.
But what's really important, it's a very important point, because these are Indigenous communities that often object to things like pipelines, and they have a different worldview, and what they see and how we see, there's a disconnect between, what you said is a cost benefit thinking or something that is very driven by, business or incentives or whatever. They see things completely different. So you're at the distinction is not, it's not that we're not on the same page. It's what I really like about what you're trying to investigate is that how do you understand that type of thinking that seems illogical, but it's not to them, because they see the potentiality, even if the potentiality of an oil spill is so little, they see it as something that is worth protecting to ensure that the rivers and streams and animals and wildlife and fish don't suffer. And that's even if, as you say, it's illogical based on the numbers that could be given to them, the chances of this happening, catastrophe. And you give other examples that we can go back to the Manhattan Project and many other things that where you can see how human beings wrestle with these types of decisions, but they're not so easy to deduce into something that's very simple, right?
So I should say that if you take a cost-benefit approach, you can get the same recommendation. Like you can get the recommendation, let's not build the pipeline based on the cost-benefit analysis. We think there's too high a risk, And the other example you mentioned was the Manhattan Project is a great example because here's something that's an absolute global catastrophe, which was during the work on the Manhattan Project. The scientists were worried that a nuclear explosion might actually ignite the nitrogen in the atmosphere and destroy the whole world. And so they actually paused the work and they spent a few days doing calculations and they realized there's just no chance. And so in the line from Arthur Compton that I included in the talk, he speaks very much like the Indigenous leader, says, if there's a chance, he doesn't care how small, we can't go on with this. So in cases of a clear global existential, threat, it seems this type of reasoning has a place, but I think it even has a place for smaller decisions. And at least I don't want to rule it out, right? I haven't made up my mind whether I think there are cases where if you've got this is a bit too formal to go into, but if you've got a certain set of structured preferences already in place, you should just use cost-benefit reasoning.
Right.
But if all you have is like an intuition that this thing is just catastrophically worse than that thing, and that's the kind of case where you don't have these well-formulated preferences, then you're reaching for a different decision framework, and that's where this comes in. So anyway, so that's the idea.
But that has to excite you as a philosopher because this is the territory you want to chart in, right?
Yeah. I think there's the overriding framework for rational choice is called Bayesian, Bayesian decision theory, Bayesian epistemology. It uses probabilities and utilities just the way I described it, and it's great. Like I like most of what's done in this framework is wonderful, but it does seem to leave certain areas, little dark corners, as I indicated, that you can't explore. You can't go there. And I think I would like to be able to make sense of this type of reasoning. And I know I feel a kind of humbleness with this Indigenous, the perspectives I don't fully understand, but it comes up in a number of places. The importance of relationships with nature. They don't actually think, the ones I've talked to are not thinking in terms of rights even and duties. They're thinking of our relationships with nature and parts of nature. And I think this might be a way of forging a kind of a link. Like they obviously, I don't think they would formalize it in the way I've done it, but I have looked at attempts to think about rights of nature, and they're also attempts to apply Western concepts, sort of Western in a sort of very general sense. That concepts from that tradition of rights that sort of evolved in the Enlightenment, applying these to Indigenous, maybe we can apply rights to nature. And this is sort of a different approach instead of doing, there is this idea of infinite value that's sort of lurking in the background, right? That nature has infinite value. And in a way, this precautionary reasoning is kind of like a way of capturing the infinity, but in a way that actually allows you to do some trade-offs. So, for example, what the paper does is it shows you how to deal with I call them simple problems where there's really only one possible catastrophe, like Northern Gateway. Those aren't so hard, and you might not even need precautionary principle for those. But what happens in a case like COVID, where you're dealing with more than one catastrophe? So there's a looming health catastrophe if you don't lock down, but there's also an potential economic catastrophe if you lock down too aggressively. So there may be more than one catastrophic outcome, and it turns out that's actually quite common. So I've seen people objecting to the precautionary principle with the following sort of example. Think of all the research going on at CERN. What if they created a black hole accidentally, and this could swallow up the whole Earth? And
I've been to CERN.
Oh, I've never been there. I'd love to go. So it's like, so if we suppose even one scientist is worried about this black hole, we should halt the research. But on the other hand, we might need the research to prevent some other sort of catastrophe. Like, so what are we supposed to do? And the problem with the precautionary principle, for many years, it was just a kind of a qualitative idea that if there's a looming catastrophe that exceeds a certain threshold of seriousness, I think I talked about in the paper, this tripod, there's a kind of a harm threshold, a knowledge threshold, and a precautionary action. So the way this precautionary principle was formulated was, if there's a serious chance of catastrophe, it exceeds some level of harm, then you should take the precautionary act. But the criticism was, what are you supposed to do when there's more than one? Yeah. You get paralyzed. So the machinery, as I call it, of this lexical approach gives you a way to do trade-offs among catastrophes without, like, it ends up being kind of like focusing your lens on the catastrophic angle of things and just ignoring the sort of lesser concerns and just focusing on preventing the catastrophes. So it's not meant to be used everywhere. No. But I think an example where it might, and you might say, how does this differ from cost-benefit reasoning? A good example might logging. So I actually looked at this. It wasn't in the paper I sent you, but I looked at a discussion of old forest logging in BC specifically. And if you use the cost-benefit model, sometimes it's also called ecosystem services. So the idea is you assign values to each tree. You look at, and then you try to monetize our aesthetic value of having a forest there, and maybe assign that a monetary value, and then you basically apply cost-benefit reasoning. You say, well, we should log. Maybe Macmillan Bloedel would say you should log a lot of this old growth, but leave something like the Cathedral Grove. I don't know if you've ever been there on Vancouver Island. It's this little, I don't know, a couple of acres of old growth forest. We get this aesthetic value. You could just go to Cathedral Grove, and that's kind of one answer. That's a very aggressive decision, right, in terms of the environment. At the other extreme, you might have somebody like Aldo Leopold has this land ethic, like anything that harms the beauty of nature is wrong, right? So basically no logging that mars. That's sort of and that's some environmentalists might advocate that approach. And then I'm trying to give honest answers for what my theory would show. And I think if you make the catastrophe something like the disappearance of a viable old growth forest, then it turns out that the principle recommends halting logging at the point where the probability of that occurring starts to go up. So it's somewhere in the middle. Like, it allows some logging, but you should halt the logging. Now, of course, in practice, hard to determine when that happens, but at least the concept is somewhere in the middle, right? The idea is, yes, you can log some of the old growth, but at the point where you're starting to raise the chance that it will not be a viable forest, that it will disappear, right? You can't 100% know this. That's the point where you should halt. So it's a more conservative position than the cost-benefit approach. It's maybe a little more favorable to other considerations than environmental, than an environmentalist position like Aldo Leopold's would be. So I think you do get actual recommendations that are at least conceptually somewhat balanced is kind of the hope anyway. And does that make sense, what I just described?
Yeah, and I think maybe we'll backtrack just a bit, because your undergrad was in mathematics.
Yes.
Right? And so, I'm sure listeners are hearing the mathematical side of your research. And also you use, lots of words like models. And so maybe could you give us a little bit of, from a philosopher's perspective, how you understand something that feels very scientific and mathematical to many respects. So just to give us a little bit of a sense of that, because that I could be wrong, but it sounds to me that you started off in math and something drew you to philosophy.
Yeah.
So maybe you could just bring us there for a moment.
So that's actually, I don't know, that is totally correct. I did a math specialist as my first degree, and I actually started a PhD in math.
Really?
Yeah, and then I dropped out.
Oh.
But I started a PhD in math, and but
wow.
But I was drawn. I love the style of thinking and the precision, and I'll say a little bit more about this in a minute. But it's kind of ironic that what got me interested in philosophy was actually a math course, but it wasn't. It wasn't philosophy of, like, when people talk about philosophy of mathematics, they often are concerned with set theory and sort of number concepts and, what do these concepts mean? And for me, it was a second year course where the professor had this really innovative way of almost torturing the math to get, like, he was trying to make sense of a geometric intuition about what's called the area of a manifold. It's sort of like imagine a kind of a surface area on a plane that's kind of curvy, and how do you define its surface area? And there's a standard definition in math textbooks, and he wanted to give this other way as kind of a limiting construction involving sort of enclosing three-dimensional surfaces that gradually shrink. And I love this, and I actually have put this same idea to work in some philosophy papers where you really want to capture a concept precisely. You need these formal tools. Yeah. So that actually really interested me in philosophy. So I took a year off. I did a master's, and I decided I wanted to move into philosophy. I knew you're giving up something in terms of the depth of precision and the level you can go, but in return, you get a kind of a very broad range of problems that you can think about. And that's kind of what I like about philosophy, is there's like huge range of topics.
Yes.
And I didn't realize at the time, but this kind of puts me a little bit in company with the history of philosophy in the 20th century. So in the early 20th century, there was a lot of optimism in philosophy of science in particular, which kind of comes from new developments in logic and science, really. And they thought we could make philosophy scientific and use scientific models to think about things. And there are a lot of famous names from this period. May not be famous to people who aren't philosophers, but people like Carnap and Reichenbach who tried to develop these formal tools. And what happened is they realized not too long after, people realize the limitations of these approaches, right? The real world is not so exact. And any model you adopt that's mathematical is going to be wrong in certain ways. Yeah. And it's same is true, absolutely true of my work. It works sometimes, doesn't work other times, but it's always interesting and instructive. That's kind of how I feel about it. And what you had in the 60s, a name that's more familiar to people might be Thomas Kuhn, Structure of Scientific Revolution. So this was a very famous work in the 20th century philosophy where he looked at actual history of science, and he said, if you look at the way science actually evolves, it's very different from the way these philosophers tend to think of science, or at least some of them. And so then there was a kind of a reaction and a move towards much more historically oriented philosophy. And now there's a kind of a spectrum where some people are still doing very formal work. Others are doing very historically oriented work and kind of working even with scientists and trying to figure out what their methods are. And the stuff I'm doing on actually analogies and on this is sort of in the middle. I kind of see a value in a middle ground where you're abstracting a little bit from any particular topic in science. You're not just looking at, what was Darwin doing in the 1860s or 1840s or whatever. But you're looking at patterns that are a little broader, but you're not trying to give some kind of logic of science that was the problem was the success of basic logic that you use in math was so great that this kind of inspired people to say maybe we can give a kind of a logical approach. Anyway, I will stop. I'm talking to you. But anyway, so I kind of see what I'm doing as kind of tongue-in-cheek, trying to carry out some of this program, but recognizing its limits, right? That it has limits. But so I have that background from my own history, just sort of starting out in mathematics and loving this formal approach to things, and really trying to develop models that are pretty clear and sharp.
And so tell me if you can describe what these models are.
Yeah, so actually the precautionary one is only a little bit different from the standard model, which I described it a little while ago, but this, you kind of do a decision table where you put out utilities and probabilities and you do the calculation. So the precautionary principle has been advanced as a kind of a rival principle. I think
it's a mathematical calculation.
It is a mathematical. Yes. Decision theory is quite mathematical, but it's not very hard mathematics, at least. But
I'm not sure if I could do it. But I mean, I would like to learn.
And actually, once you develop it and it seems reasonable, it kind of gets absorbed by other disciplines. Like economists use this, and it's not anything special. But this precautionary principle, the way I think of it, is what you really need to do is to treat, instead of the utilities being a single number, like 10 or 100 or negative 1,000, it's like a vector.
Oh, okay.
And it's got two components. The first one is flagging whether there's a catastrophe or not, and that's the catastrophe dimension. And the second is everything else, all the other values. And I'll give you a simple example to illustrate how this would go. Okay. So let's say you're trying to rent an apartment near UBC, and you absolutely, above all else, value being within 5 kilometers of UBC. And that's locally a catastrophe, so to speak, if your house or your apartment is more than 5 kilometers away. So I'm making it deliberately look bad for these vector utilities. So you would then say anything over 5 kilometers is like, I call it -1. It's like a disaster. And anything less than 5 kilometers, I give it a 0. It's fine. It has no catastrophe. And then the other vector component has all the other things, like how nice is the apartment, how new is the apartment. And so then when you make your decision, what you do is you when you're comparing two apartments, you look at the first component. Is it catastrophe or not? And only after that do you look at these other values, right? This is the idea of a lexical utility or a vector utility. You first compare, you look at the first component, and only after you're sure that the two things are equal do you look at the second component. Does this make any sense? So it turns out that I'm not giving you the gory detail, but if you do this with all of these kinds of decisions involving catastrophe, you don't actually need a new precautionary principle. It's just it's still maximizing expected utility, the same idea as standard decision theory, but using vector utilities instead of a single number utility. So it's kind of elegant. It's a generalization of normal decision theory. But anyway, I don't know if I may have said too much.
That's great.
So it's kind of it is math, and it does get harder once you get into these trade-offs. Like it turns out, for example, like we have one paper we're trying to do this in as neutral a way as we can. So we're very liberal about what counts as catastrophe. So I'm with a group of people, and we even looked at a paper about climate change targets, temperature targets for global temperature rise. And we said, what somebody might regard as catastrophic or not, part of this might depend on whether they're exporting fossil fuels, right? And we have to allow that for some countries like Canada, sadly, which depend on this, that they might consider certain kinds of outcomes an economic catastrophe. But against this, there's the climate catastrophe. So this is one of these trade-off cases. And what we did in this paper, we argued that even the fossil fuel exporting countries have reason to seek a pretty aggressive mitigation target. So there's a little bit of math there because you're looking at these kinds of graphs of probabilities of different catastrophes, and you're finding a point at which sort of the marginal probabilities of the two catastrophes are equal. So this is a little bit like economics, some of this stuff. So it does get a little mathematical, but the basic concept is there's just a slight generalization of normal decision theory. Does that, I don't know if that makes
Oh, yeah,
any sense.
100%.
Okay. Yeah.
Now, let's go back to COVID for a bit, because something in your paper was quite interesting, that when they were looking at numbers of, deaths to the illness versus deaths that were not necessarily had anything to do with the illness, but maybe lockdowns had caused undue harm, people that were isolated, people that, suffered tremendously in terms of their mental health, could have ended up in the statistics that you wouldn't expect when you're thinking, because COVID is I think a classic example that is not so cut and dry when it comes to how you can apply some of these models, right? Yeah,
that's certainly true. And as I said, like a few minutes ago, I'm really leery of claiming too much for this. It's like still kind of conceptual, but it's a great example, because mortality, even if you focus, you say the one thing this approach does is it says let's not try to take everything into account. Let's not look at all quality of life. You like a cost benefit analysis. If you're thinking of lockdown versus no lockdown, or how long should the lockdown last? If you're using standard cost benefit analysis, you have to look at everything, like quality of life, and maybe that will strike people as exactly right. But this other approach, which focuses on precaution and catastrophe, says you actually zero in on something like mortality, But it's not all COVID. It's not all the mortality is coming from COVID. Some of it is coming from people who don't get medical treatment, or people who commit suicide. So even if you just focus on mortality, there is mortality that's not directly attributable to COVID. It might even be attributable to the precaution, to the lockdown, right? So the fact is, you still need a tool that kind of balances the prevention of these different catastrophes. And that's kind of what this theory does. And it gives you, I think it will give you a recommendation that it will be more aggressive about preventing mortality due to COVID than you would get from a standard cost benefit approach, which would give a lot more weight to these other factors, quality of life and so on. And you might disagree with the recommendation that our principle gives, but it's at least an interesting alternative, right? Like if it allows you to get to a decision more quickly, because you don't have to think about all of the costs and benefits. You're just focusing on dimensions you've identified as the most important in terms of what's a catastrophe here, right? So anyway,
it's very interesting. It was a very interesting example, because not only, like, even when we use the word lockdown, we can understand how that may have looked in British Columbia, under Bonnie Henry, for example. But then you move to another place, go down to Argentina, one of the longest lockdowns ever, right? And you get a very strong variation of how a pandemic was understood by the various governments all over the world, and even interprovincially, right? So it's fascinating, because it shows how difficult it is to understand even something like death numbers, right?
Yeah, and I immediately have to be, backing off a lot and saying I'm humbled when I think about any actual example. And there are a gazillion questions. When do you halt this? Like, what? It's not just lockdown or not. It's like a variable. How long is the lockdown? How severe is the lockdown? And how do you justify this to people whose livelihoods are being harmed? So I fully admit that this isn't something to be applied in a simplistic way. It's really a concept that allows you to think in a slightly new way, but it needs a lot of work if it were ever going to be applied.
But that's what you're on to, which is interesting, because even the words itself, precautionary reasoning, is very interesting philosophically. And you got me so interested that I said we wouldn't talk about analogical reasoning, and then I changed my mind this morning when I started to read about analogical reasoning a little more. they're connected, but they're not. They're different. So do you feel that we could leave? I mean, do you want
that's
to talk?
fine.
Do you think we've done?
Well, I
that?
mean, I didn't explain everything, but that's fine.
No,
I mean,
but if there's something that
I'm just trying to think if there's anything else that
you can bring
the
in.
only thing I will add is like the latest stuff I'm doing is trying to develop a series of more sophisticated models. So like you might start with COVID, for example, you might start with this really simple model, lockdown or not, and then you get one answer, and then you treat it as a variable, and you get much, and there's some problems that will probably pop up in people's minds about how sensitive this decision is to where you arbitrarily draw the line at what counts as catastrophe or not. And it turns out if you go to a more sophisticated model, that disappears. I'm not able, it's cheap for me to say that because we don't have time, but actually that's kind of what that paper I sent you, we were trying to argue that once you move to these more sophisticated models, you're able to answer these worries about how sensitive the recommendation is to some arbitrary cutoff point. And I think I'm trying to develop a view that this is not the right way to think about the precaution principle, that there's some sharp cutoff where, one more person dies, it's catastrophe, one less, it's not. Like, it's totally wrong. It's each one is a catastrophe, and you have to anyway. So this is mainly just trying to head off obvious objections that anyone listening will think of. But anyway, but I'm happy to move on to analogical reasoning.
Because that is a big part of your life's work. And you are one of the leading experts in the world. Was I right when I introduced you like that?
I guess, I mean, what I will say is this, that lots of people have talked about this sort of, models of belief revision and what I call Bayesian epistemology and Bayesian philosophy of science, and sort of modeling the way science evolves in terms of probability and how we test and so on. But not many people have thought about analogical reasoning, and it's very hard. There are some people who have very good books on it, but not a lot. But it's used all over the place, and we all use it in daily life. It's used in legal reasoning.
Yep.
When you appeal to a precedent, you're reasoning by analogy. So, like, just a very simple example I like is this life on other planets example. So
I interviewed back-to-back two astrophysicists from UBC. So Jamie Matthews and Michelle Kunimoto.
Oh, terrific.
Who's actually, I learned responsible for many of the thousands of exoplanets.
Oh, the exoplanets,
that have been discovered. So actually, we've got that inference is becoming, who knows, you're looking for, Thomas Reid made this argument about life on Mars or something in the, 18th century or something. People have been interested in this idea that, well, there's life on Earth. Could there be life elsewhere? And we don't, in the absence of, solid evidence, we use analogies, right? Yeah. So we say, well, we give our best effort at explaining life on Earth, and then we look for the factors that were there in that explanation, and we see whether they're present on Mars or whatever that moon is of. I think there's one of the Uranus or Neptune has a moon that is a candidate now for harboring life. Because they've got kind of liquid. I should know the name.
Yeah.
But there is a mission that's going to go there.
Or certainly exoplanets. So what? Anyway, so that's an example. Actually, I'm really fascinated with what I call generally remote targets. So sometimes there's some object we're trying to reason about that's inaccessible because it's gone. It's in the historical past, like ancient civilization or ancient biology. So it's remote historically, but it could also be just remote in terms of distance. So black holes, there's a huge debate on now about can we confirm some of our models of black holes using analogies. Yeah. So, and I can even explain a tiny bit about this. So,
please
and it
do.
all started at UBC because Bill Unruh,
Oh.
I don't know if you've ever interviewed him.
Oh, I should.
So he's got this.
Is he still around? Yeah.
He's still around. I think he's got this dumb whole idea that, so like if you can think of a waterfall,
Yeah.
and imagine that you put a radio speaker behind the waterfall, and now the water is flowing faster than the speed of sound,
Oh, cool.
300 meters a second. So now the sound can't escape.
No.
So it's kind of like a sonic analog of a black
cool.
hole, right? So, so and so maybe we could kind of study these sonic analogs and learn things about real black holes. Anyway, very crudely explained, but it turned out like this idea, which I don't know when, I think it was in the 90s or anyway, it's been refined, and they have these much more sophisticated analogs now that use these Bose-Einstein condensates or quantum fluids or whatever, and they can oh, I'm knocking the microphone out of the way. They can actually they think that they might have the same structure in some ways as a real black hole. And so one of the predictions for a real black hole is Stephen Hawking's prediction of radiation. This very weak Hawking information is leaking from a black hole. They actually evaporate over billions of years. So it's not true that nothing escapes, right? Because of quantum effects, you get some leakage, as it were. And so Hawking's model had some mathematical weaknesses. Bill Unruh and a student of his made some amendments to this model. And people have done, supposedly in the last few years, have created these tabletop analogs where they've observed analogs of Hawking radiation. So suddenly philosophy is important, right? Because, and I talked to Unruh, and I don't think he would call this, he never said I would call this confirmation.
No.
He said it's a proof of concept. Like it shows that maybe there's something to this model, that it could work for this special case. But there are a bunch of philosophers who say, well, it actually provides evidence that if you were actually to get close enough to a real black hole, you would observe this. So this is an example of a remote target, I call it. In an analogy, you've got a source domain, which is the familiar close object that you know something about. And then you've got a target, which is the object you're trying to draw a conclusion about. Mm-hmm. And if the target is not accessible any other way, sometimes analogy is the only way you can make inferences about it. And one last example of a remote target would be ethically remote. So like humans are in some ways a remote target for certain kinds of tests, like drug testing. Eventually they test them on real humans, but initially humans are off limits because of ethics, right? We don't want to. So we need to use surrogates, like whether it's I don't know. They have all these sophisticated ways. They sometimes use
I
animals.
like that word, though.
Yeah. Surrogates?
Yeah. Why not?
Well, there's actually a concept in philosophy called surrogative reasoning.
Is there? Oh, of course.
Where you use some other device to reason about. It's more general than analogical reasoning. Basically, all modeling is surrogative reasoning. But so you're studying an animal model, or you're studying like a kind of a bit of cell tissue or something. Or maybe you use a computer model to do analogical reasoning. Anyway, so remote targets is a fascinating case where analogical reasoning may be the best we have. And so I'm interested in that. Anyway, so this gives you some idea. I think sometimes people wonder whether philosophy has any use. And I think it comes up in these cases, again, at the margins of good science, where we're trying to extend our methods, and we're not sure whether the standard approaches to evidence are valid. Sometimes scientists will talk to philosophers about this stuff and say, what do you think? Is this like, I don't think they take it too seriously, but they are interested in hearing what philosophers think.
Well, in the past, a lot of these disciplines were one, right? You could make an argument about that. I'm sure, where the crossover was very much a thing, right? So your research in analogical reasoning. You mentioned physics, but it even touches things like archaeology, right?
Yeah, archaeology, absolutely.
Law, 100%, and that makes sense. But the key word is also plausible, right? Like is that right?
So actually, this is an excellent question. So analogical arguments vary in strength. And when I wrote my book, 15 years ago now, I decided I was just going to focus on a very weak use of analogical arguments, which is what I called plausibility, because I think this is a kind of and I was focusing on scientific uses of analogy, and I said, really, there's a stage of scientific reasoning where you need, before you put a lot of work into testing and setting up experiments, you need to be convinced that you have an idea that has a chance. It's plausible, and that's where analogies come in. So the greatest example of this is Darwin.
Yes.
So he has a book where he accumulates massive amounts of evidence for natural selection, but he starts by talking about artificial selection. Now, there's scholarly debate about whether they're even different, but I think he was actually guided by a philosopher of science. I think it was whether Whewell or Herschel, I'm trying to remember.
Yeah.
Who
possibly.
They were scientists, philosophers who
Yes.
they articulated what's called the vera causa principle, which is any new theory in science, to be taken seriously, needs to be a true cause. It needs to exhibit analogy with something already known to operate causally in the world. So Darwin is showing that selection is a real force in the world. We know it's real because we see it at work with pigeon breeders and so on. So he was very influenced by the philosophers of science. And he was using this stage of plausibility reasoning. And so in the book, I focused on analogies as a way of demonstrating plausibility. And actually, I have a whole chapter on mathematical. Analogies are used all over the place in mathematics. You wouldn't think so, because you have this lovely deductive reasoning. But no mathematician is going to spend hours and hours thinking about a hard problem unless they think, it's kind of like this other thing. Yeah. And so plausibility reasoning is very important in mathematics, and it's clearly not the same as a solid proof, right? So anyway, so I was very interested in this, but that doesn't mean there aren't really strong, compelling. So there are much stronger analogies. And I didn't really focus on them, and people have scolded me for this. Like, the book doesn't really look at really, really powerful, strong analogies. So good examples would be in physics, like scale models. If you want to test how an airplane might function, you might use a wind tunnel with a little scale model of the plane. And if this is done right, you've got really, really strong evidence for how the real plane is going to behave, right? And I thought this was not too difficult, but I was told, no, you're completely wrong. This is really hard stuff. It's really interesting uses of analogy, and it's kind of left out of my book. But anyway, I'm coming back to that. So I'd like to look at really compelling analogies. But anyway, that wasn't in the book. So
now we have only three minutes.
Oh, I wasn't keeping track.
I did mention AI,
okay,
and you mentioned it in your email to me. So what can you say in 3 minutes? Because that's exciting stuff.
Yeah. So
and it really is changing. It's whether you even question this idea of a what is. I'll let you. Let you explain it. But
so it's hair raising.
Like it's hair raising, and it's asking questions that really weren't asked.
No.
Right before.
So there's actually a long tradition. Part of the evidence that analogical reasoning is really important is machine learning. People have been studying this since the 80s. Models of analogical reasoning, computational models. But this was the old style AI, where you actually had symbolic manipulation and algorithms to do analogical reasoning. And as recently as 2020, I read a paper by Melanie Mitchell, who was Hofstadter, Douglas Hofstadter, Gödel, Escherbach. Anyway, he's a very eminent kind of computer scientist with philosophical. Anyway, Melanie Mitchell was his student. She's like, well, none of these computational programs really work that well. They're all interesting. We don't and then 3 or 4 years later, there were papers out about how well ChatGPT, and this isn't even the latest chat, how well it
was
does
the earlier
analogical reasoning.
ChatGPT. Yeah.
And they go through all these benchmark tests, with shapes and so on, and the AI outperforms college students. And then the last page of the article is like, this is an emergent ability and we don't really know how it does it. Like, so I went to a talk 2 weeks ago where somebody was actually talking about I went to two. One was about basic logic. One was about my stuff on analogy.
Yeah.
And they're like, well, actually it does pretty well in analogical reasoning, but it doesn't use Paul Bartha's theory. Like I didn't even talk about my theory of analogies. But anyway, so I don't think it's doing good analogical reasoning. It's just using these LLM methods, which is statistical prediction of the next token or whatever. And it does it really well. So do we even need a normative philosophical theory, right? And this is what I'm saying, I know we only have a minute. One answer is you don't need them. You can throw them out the door. You can just start using these models and not worry about the philosophy anymore. In the book, I argued we need both. We should keep doing these computational models, but we should still be thinking about what makes them work. So I would like to think about this in the coming year, but obviously as a philosopher, I want to be honest, and in the end I may concede, this is right, we don't need philosophy, but I'd like to think about the objections. And
Did you just say that?
What did I say?
We don't need philosophy.
I may be never coming back again. I suspect that's true anyway. But anyway, so one cheap argument is they're not 100% reliable, right? Like if you were a lawyer relying on AI, you might get a very bad. So, but I think maybe they'll let's set that aside because they're pretty good. Another argument, I've seen an interesting argument that these centaur systems, have you heard this term? You pair up a human expert with a program, and sometimes they can outperform the program. Like the human is kind of fine tuning, but I don't have a lot of faith in that answer either. The third answer, I think, is human flourishing is about reasoning and thinking hard and coming up with new ideas. And I think analogies are used in that way too. And I think for that, you actually need a kind of a model that isn't the way the AI thinks. It's a way a human could think. Yeah. And the last is just me. Yeah. Like, I'm just curious. Yeah. Like, I want to understand why an analogy is good. Why is an analogical argument good? And the AI is never going to provide that, right? Yeah. Like it may spit out arguments that we think are intuitively good, but what makes them good? And for that, you need a philosophical theory. So that's kind of my quick answer.
That's a really great way to end the show. Wow. So, I love this conversation.
Well, I
hope you enjoyed this.
I did. And I hope it makes sense to people. And
great. This is great. And so if you've just heard the end here, I've been speaking with Professor of Philosophy Paul Bartha from UBC here, and we've had a wonderful discussion that took us from precautionary reasoning all the way to analogical reasoning, and I think ending with some question marks about AI is a really good way to end. But it is exciting stuff, and I hope it keeps you motivated, because that's ultimately the goal of any philosopher. It's the why. It's the
asking
continuous questioning. And I love that Socrates. Oh, I love him. So anyway, my name is Farah Guerrero. You've been listening to the Blue Hour on CITR 101.9 FM. This will be podcasted on CITR.ca, and as well a partial transcript and audio links will be on my blog on which is thehourisblue.com. Thank you, Paul, for coming in.
Thank you very much, Farha.
Yeah, thank you.